Remember the Bronsted-Lowry acids and bases definition. So the Bronsted-Lowry acid definition is that it will donate a proton. The Bronsted-Lowry base is the one that accepts the proton. Then we have the conjugate acids and bases. These differ by one proton from the species in the reactants. So let's have a look at this example. We've got ammonia and water. What's happening to the proton? We can see that in this particular case, water is donating a proton to the ammonia. Okay, because we've got NH4 over here, so it's one more proton than ammonia. So, in this particular case, water has to be the acid, which means that because water has donated the proton and ammonia has accepted the proton, ammonia is the base. Now we need to look on the product side to see which species differs by one proton. Let's have a look. We've got the ammonium ion and the hydroxide ion. So the hydroxide ion differs from water by one proton. So it is the conjugate base. The ammonium ion differs from ammonia by one proton. It's the conjugate acid. So you need to decide what the conjugate acid-base pairs are. Sometimes it's easiest to do that first, and you're looking for a difference of one proton. Once you've decided what the conjugate pairs are, have a look at the reactants and decide which species is donating the proton and which species is accepting the proton to work out where your acid and base is in your reactants. Then the conjugate base is going to be the product species that differs from the reactants by one proton, the acid reactant. Then look and find out which species in the products differs from the base in the reactants by one proton. This will be the conjugate acid for the reactant that was the base. Okay, another example. We've got the ethanoate ion and hydrochloric acid. So what's happening in this reactants? So let's have a look. We've got hydrochloric acid and we've got the chloride ion. We've got ethanoate and we've got ethanoic acid. Okay, so what's happening to the proton in the reactants? We can see that the proton is moving from this one to this one. So the proton is being donated from the hydrochloric acid and accepted by the ethanoate ion. That means this one is the Bronsted-Lowry acid and this one is the Bronsted-Lowry base. So if that's the base, then the ethanoic acid would be the conjugate acid. And for the hydrochloric acid, the chloride ion would be the conjugate base. Looking at the next example, we have ethanoic acid and we have water. So what's happening here? We need to find the pairs first. So what's the difference in the products of one hydrogen ion? So in this particular case, the ethanoate ion is one hydrogen ion different from ethanoic acid. And the hydronium ion is one proton different from water. So what's happening in this reaction? Where is the hydrogen ion going? If we have a look back at our reactants, we can see that this hydrogen ion from the ethanoic acid is being donated to the water molecule. So the proton is being donated from the ethanoic acid to the water molecule. That means the ethanoic acid is the acid, it's the proton donor, and the water molecule is the base. It's accepting that proton. So therefore, the conjugate base for the acid must be the ethanoate ion, and the conjugate acid for the base must be the hydronium ion.